Today we continue talk this book, Electromagnetic Wave Theory of Photons. In this book, the most important law is mutual energy flow theories, and it is also the law mutual energy flow theory or law. We continue call this. Today, last course we got mutual energy theories. Mutual energy theorem is writing this. This is mutual energy theories. Here has a situations has G1 and also has a current G2. So this send a field C1. This will send a field C2. C2 equals E1 H1. C1 equals this is retarded wave. This is advanced wave. So this is source. This is sink. So this current is sink. This current is source. Source usually like transmitting antenna. This is like a receiving antenna. In the transformer case, this is primary or first call. This is secondary call. Okay, and we got Huygens principle. The Huygens principle is very easy to get. Actually, it is just move one current outside. G1 move one outside. G2 is here. First, we know there has this is theorem. We also can call it is some kind of reciprocity theory, because only me call it is mutual energy theorem. All other people call it is reciprocity theories. In this case, since one is moved to outside, inside only one here, so like this formula is only one inside, so we can just copy this. we post here. Okay. Adjust this formula. We put minus sign here. Since inside no, we here has only one current, J1. Only this. This guy is out. So in this case, we can just move out this part. Or move out this part. And then here has also we can see this is equal this. These two parts are equal. So we get this equal that and equal that equal that. We rewrite. So equal this. And equal this. We get this. In this formula, consider this will become X So this is like a green function. So this guy is green functions. You use current and green functions, you can calculate the electric field. If you got an electric field, you also can get E1's Y, similar method, E1's Z, and hence you can get the whole E1. You can get. And here, that means if you do not know the current, however, if you know the electric field E1 in the gamma, and also H1 in the gamma, and the field outside, like this point, E1x, can be get from E1 gamma. So this is, since you calculate is come to the surface, this is called Huygens principle. We just have got this formula. We got this formula. We can also move this formula. We post this here. For this formula, this is one step. This formula is one step we get Huygens principle. We move this part. This is 1. This is 2. So we can write in this formula as here. Okay, this we just rearranged the formula as this, and we can see this inside has a current J1, here outside as J2. This is N and gamma. In this formula, here we actually calculated the energy flow, because this is mutual energy flow, and this part is produced energy from J1 is the source. This is source. Source created energy from this created energy outside energy is this part, and this is energy go inside the J1. Is this, and the gamma actually do not need just the surrounding this. We can take the gamma, we can change the gamma as actually any surface gamma will separated J1 and J2 is okay. So I call the above formula as mu energy flow theorem. From mathematics, we can see the mutual energy flow theorem is exactly same as Huygens principle. However, when we speak about Huygens principle, think it is a mathematical formula. When we speak, this formula is a mutual energy flow theory. We will think it is energy theorem is a physical series. It is a physics theorem. that is different. And it should be speak. I introduced energy series in 1987, and introduced the Huygens in 1989. However, I introduced mutual energy flow is in around 30 years later. That means even you got a formula, the mathematical formula is there. However, to understand that formula, need a very long time to understand that. For this formula, perhaps it is only me call it is a mutual energy. Only me call it is a mutual energy flow series. Other people will still call it is a reciprocity series, because it is involved advanced wave that is need negative time and time reverse processing, so it's very confused to many people for this formula. Another thing is, when I got this mutual energy flow theorem, I began to use that. However, I immediately found here has something wrong. Here has something wrong. Let me to show you something wrong. For this formula, we copy that. For this formula, I found the mutual energy flow. This need here need a constant. Otherwise, because you can compare with Poynting series. For example, the formula Poynting theorems. This is Poynting series. This is same. This is also nearly same. Or at least we also know H1, H2 at least is same. Then here is only one term. Here you have two terms. Oh, there are two terms. That is the reason here need this. So to adjust, this need a half here. So I will think why this formula need a half. Later I found if you here need a half, that means you need you need to do this like J current go to 2 times current to replace the formula. Or you need E go to in the original formula and you can get the original formula. For example, if we take this out and use this formula, then here we'll add up a 2. Here J2 become 2 times J2, and this 2, if you take it away, it will come here. Come here. So you got a half here, and you got a correct formula. In other situations, all you can do is we take that away. You put a here and here, put a here, half here, put a half here. Here need also put a half. Here need put a half. And after you delete one half, and here has a half, and you take this half out. You take this half out. You got a correct formulas. But what means this? This means you need corrected. You need correct. Maxwell equation, especially all other Maxwell equation you do not need to correct, but only one perhaps you need is correct is the Ampere's circle law. Originally, your Ampere's circle law is this. Now you need to put a half here. That means you use G to change. You change G to 2G. You do this. Or you do another way if you put a half here, is also okay. Put a half here. Here also put a half. That is also okay. That means you use E field to change it to. You do this convert. So anyway, okay. The corrected Maxwell equation is this. And the other things you do not need to correct. For example, this you can still keep. I'm writing down wrong. This is not E. this make a mistake, big mistake. This is H. So other things like E, this you do not need to correct. And certainly, this is also not need correct. However, this guy this need also, you need to same as this, put a 2 here. Why we need to do this corrections? Later, I think it is clear. So, original Maxwell theory if you have a current, an antenna here, that produced field. So the field is all produced by field is produced by source. However, in my situations, I have a receiving antenna. It is also produced field. This field is advanced wave. Here has E2, here has E1. If you ask E, that actually is E1 plus E2. In this case, the E1 should be, so originally you only has E1, now you have E2 that. That is the reason we need to do this. To do E go to half in the formula. Oh, that is the reason this is also is not introduced by me first. That if you add up sink's field, this is sink. Oh. You need half retarded and 1/3 field. Oh, you need a half retarded and half advanced field. So that is the reason we need to do this in the formula. This is also the reason in the Maxwell equations, here has a second, here has a 2, here has a 2. So the field is produced half. That means anytime if here it has a current G, will produce not only produce C retarded plus C advanced, C equals E and H, C R equals C advanced okay, we need to correct Maxwell equation this way. This is not the only corrections. We said we got this formula. We continue copy this again. Okay, we got this formula. Do not need this guy. This is our formula. The copy is something copied me very wrong. Okay, this is our formula. We should tell us this formula is still got from Maxwell equations. So in this case, we should write in here actually we need to write in here M This M is the magnetic field get from Maxwell equation. In my series, I will writing like a Maxwell equation as we will write a Maxwell equation this way because I have taught Maxwell equation that has bugs. To correct this bug, you still use Maxwell equation to calculate the magnetic field and also electric field. Electric field is not so important. We not correct that because even that has something also wrong. However, is for the electromagnetic wave, E is mostly important is the induced electric field. So we only consider along the A part. So this part do not need to correct. Perhaps you need to correct is something like static E. This you need to correct, but this is not important. Not important for wave. For example, plane waves. That is the reason we use this Maxwell equation. You from Maxwell equation, you got this formula. Perhaps you add up two here. These two produced this guy. However, this is still also is still wrong. This still wrong. What is correct way? Correct formula is we need to take m out. That is correct. Oh, this is correct. Oh, okay. So that means for mutual energy flow series, originally you should here should has a Maxwell. This is the formula we get from Maxwell equation. However, this Maxwell equation still, or this mutual energy flow theorem is still wrong. I tried a lot of time to, for example, transformer for antenna. It is not work. I will tell you later why it is not work, but no, I just tell you we need to if it is need to make it work, we need to take this away. Take Maxwell away. Not correct. Not use original formula. Why is this situations? I will tell you this formula actually is not get from Maxwell equation. But get from quasi static Maxwell equation. What is quasi-static Maxwell equation? That is, you need to take away displacement current. So, for example, Faraday law is still here. But for Ampere's law, just this. Oh, this is quasi-static. And if it is all, perhaps you can also add up this ds can only equals epsilon 0. So this is quasi-static Maxwell equations. We can also still call this is Maxwell equations. We know d that is equal to here has this part. If it has this, then this is this current. So this is not it is also displacement current, but not total, not all displacement current. Is only part. This is static part of displacement current. That means we from this we can also got a derived cross Poynting series. And we can from Poynting series derived mutual energy theory. And from mutual energy theory derived mutual energy flow theory. However, this mutual energy flow theorems is got from quasi-static electric phase. Is still not from radiation field. We need generated from this. Generalized to radiation or electromagnetic wave situation. What means this? This means our mutual energy flow series is not got from Maxwell equations. It is got from this way. First, from quasi-static electromagnetic field, and then prove it is from Poynting series, and similar as derived as before to get a mutual energy theorem, and continue get a mutual energy flow series. However, this mutual energy flow theorem is still in quasi-static electromagnetic field. Generated it is to radiation electromagnetic wave situations. This way we get the mutual energy flow series. And we have said the inside the what is the M, I or H. The H need to be corrected from something get from Maxwell equations for retarded field, or perhaps only for far field. For advanced field, For near field, do not need to correct, but for far field. However, electromagnetic wave is usually the far field, so this is most important correction. So that means Maxwell equation is only mathematic formula. Is not energy, not a physics law. What is the energy? The mutual energy flow theorem is a law, physics law, and also we have said the corrections we have done is this only can real part. This is a law, physics law. This is called Asian do not overflow the universe. This law is the radiation do not overflow universe. That means if here is a gamma, you have a G1 has a field Cos1, the radiation, if the gamma, the radio become infinite, the field should be zero. This also can be realized For example, that means if your electric field and magnetic field has 90 degrees in phase, the electromagnetic wave will be reactive. Reactive power wave. This wave do not send energy outside the universe. In the end, I will tell Maxwell electromagnetic wave theory is wrong in here. Actually, electromagnetic wave is electromagnetic wave is a reactive wave. This wave, even it is send the wave outside, however, it is not really carried energies. The energy is sent out, however, it is also come back in time reverse. So the wave not really sent out. That is the really reason in quantum mechanics we said wave is a probability wave. That is true. Wave is probability wave, and wave is reactive energy wave, reactive power energy wave. That is actually same things. And when wave is reactive power wave, the wave do not need to collapse. The wave do not need to collapse anymore. So the wave not send energy. The energy is transmitted only by mutual energy flow. In this case, the mutual energy flow is the particle. In the electromagnetic wave situation, the mutual energy flow is the photons. It is the photon. So this theory, we try to solve what is photons, what is particle, what is wave-particle dualities. We will give a solution of this. That is the reason we need to correct Maxwell electromagnetic wave theory. If you from Maxwell equation you cannot get this result, we must correct Maxwell equations, Maxwell theories. This correction, after the correction, electromagnetic wave is a reactive power wave. Okay, this is today. Thank you very much to hear my talk.